Okay, so I did my presentation on the Natural Bridges National Monument located in southeast Utah. To start off, we're going to start with the geological features. If you remember in the last slide, and if not, there'll be more in the next slide, there was an arch kind of formed in the bridge, and if you look close enough, you can see kind of little ripples or waves. Basically, this is cross-bedding. Cross-bedding is a common type of layering of sand and mud and other materials. And what happens is the beds on inclined surfaces get layered and layered and layered, and eventually it'll cause the ripples or dunes you see. It can be concluded from research that this happens from forceful wind or water or any type of weather. So basically, 10 million years ago, plates collided and pushed the layers from the crossbedding, and it created the Colorado Plateau, which slowly created the canyons. Water eventually caused these canyons to separate within time, and it created thin structured bridges, which eventually created this monument. Okay, so before we go any further, I'm going to introduce the multiple choice questions. Number 1, which bridge is the smallest and oldest? Number 2, weathering and erosion are the same. Number 3, Kachina means. Number 4, what naturally carved these bridges? And number 5, what is the most important factor of erosion? Touching a little more on erosion, basically erosion works away at the rock, creating these little delicacies, as you can see in this close-up picture I put. You can see there's different grooves and lines and colors, which indicates that erosion happens at different rates, which makes each structure unique. You can't tell a structure or like a rock that's been eroded its exact age, and one of the most important factors in erosion is climate. The items you'll need for this demonstration is a fan and some rocks of all different sizes. This is a close-up of what the next part should look like. Okay, so here I'm showing you the different sizes of the rocks I brought in. Basically I got small, these as you can see are the really small ones, I got a few bigger ones. So basically in this next part, I bring together 3 rocks so you can pretend it's one. I know it's kind of weird. And I put it in front of the wind or the fan, and so you could kind of see that over time, it erodes, which is why I take away that bigger chunk right there to show over time, it gets smaller, it gets weird. You can see the kind of curve in it. So with the fan acting as the wind and the rocks, I wanted to show that by putting these rocks in front of the wind, it would show the slow breakdown. Obviously, I wasn't going to stand with the rock in front of a fan for a million hours, but to get an overall sense. As for the weather aspect of it, layered rocks can easily be eroded. We talked about cross-bedding in an earlier slide. Basically, those are the layered rocks that are more easily eroded than others. A major factor that can be played in weather is definitely the rainfall and the temperature. There are also evidence of 2 previously collapsed bridges at the monument, and earthquake potential is so high here. I wanted to put in this slide about erosion versus weathering because I thought it was very notable. Erosion and weathering are 2 completely different things. Erosion moves materials around to a new location. Factors of erosion can be ice, water, wind, and gravity. Weathering, on the other hand, stays in place. A rock, for example, would be broken down and dissolved, and the factors of that would be mechanical, chemical, or organic. They are not the same. This national monument has 3 different bridges: Owachomo, Kachina, and Sipapu. I think that's how you say them all. So in a breakdown, Owachomo, meaning rock mound, and Hopi, was named after the rock formation at the east end of the bridge. This bridge is the smallest and the oldest from what we can conclude. It's 106 feet high, 27 feet wide, and has a span of 180 feet. It was previously named Edwin, the Little Bridge, and the Congressman. As you can see from the picture, there's a little pathway there. So the hike for this is just under 1/2 a mile round trip, and there is no water stream underneath this bridge. The next bridge we're going to talk about is Kachina. Kachina is also known as the Middle Bridge, and the name itself means dancer. It is 210 feet high, 44 feet wide, and has a span of 204 feet. This has the longest hike of all three of them. As you can see from the previous picture, this bridge is the thickest of the three bridges, and it represents an early stage, which comes to the conclusion that it may be the youngest. It also has the smallest opening of the three bridges. In June 1992, 4,000 tons of sandstone fell, enlarging the opening. The last bridge we're going to talk about is Sipapu. Sipapu is the largest bridge of the three. It is middle-aged. It is also 220 feet high, 31 feet wide, and has a span of 268 feet. The name, Sipapu, refers to the Hopi people. It is also a known fact that the opening of the bridge will eventually collapse. Next, we're going to talk about the location of the monument. As you can see in all white, this maps out the entire area of the monument. Over to the left in blue, you can see the Kachina Bridge area. And over to the right in green, it shows where the campground is. People who come to the park and want to stay overnight, they can camp out over there. The entire perimeter of this, you can take a hike. I think it's an 8-mile hike, or you can access the individual bridges from their individual paths. There's also a scenic driving route you can take to see everything. As we zoom out, we can see the monument is located at the bottom of Utah, and right next to it is Colorado, and right beneath it is Arizona and New Mexico. The Natural Bridges National Monument is actually only 50 miles away from the Four Corners. One of the reasons I chose this monument was because it was one of the places where you can go to see a million stars. Well, that was exaggerated, but basically on March 6, 2007, this monument became the first international dark sky park. It was certified by the International Dark Sky Association. It is one of the darkest places in the country. Here you can see about 15,000 or more stars. In contrast, we see about 3% of those stars in our communities. Basically, we see around 500 or less. So natural bridges aren't just found in Utah, they are found in many other places in the world. I have just a few here, and the first one I chose was the Natural Bridge of Arkansas, obviously located in Arkansas. So here you can see the Natural Bridge of Arkansas on Google Maps, and as you zoom out, you can see to the left is Oklahoma and to the right is Tennessee. Next, we have the Clifty Creek Natural Bridge located in Missouri. As you zoom out, you can see Mississippi, Kentucky, Tennessee, a bunch of states there. As you can see here, there's the Natural Bridge of Virginia zoomed in close, and as we zoom out, we can see West Virginia over to the left. Up at the top right, there's Delaware, and down at the bottom, there's North Carolina. Some interesting facts I found were that in the summer, temperatures often exceed 100 degrees. Monsoons are very common here in the late summer. There are several species of lizards found here, and this is Utah's first national monument. So here are my answers to the multiple choice, and my sources are on the next slide. I hope you guys enjoyed my presentation.